Okay, let's talk about object-oriented programming in Python. What I'm going to do here is do a very simple example of how to use this. So essentially, what I'm going to define here are two different classes. The first one is body part, and the second one is heart. And these are classes, they don't really do anything, but they're just really good at showing the syntax for creating a class. In just a moment, we'll actually extend our calculator example to include a class structure. So what this does is I'm going to create a class called body part, and the object right here, it's going to inherit from a Python object. So any of the functions that are part of object are also going to be part of body part, right? And so in Python 3, everything inherits from object no matter what. But with Python 2, we actually have to specify that it inherits from a generic Python object. And the only thing that I'm going to define inside of this body part is the init function. So every single class will have an underscore underscore init underscore underscore. And so this is part of a Pythonic convention for classes. Any of the classes that are immediately available because it's just a class will be given by the underscore underscore and end in underscore underscore. So this initialization function is something that every single class has. It's a class method, right? So it's also hidden to the user. We never actually call the init function. It's called for us, right? And I'll show you what I mean by that in just a moment. So body part right here, it takes as input self and name. Now, self is simply a keyword in Python that is always passed into. It's always the first argument for a method that is part of a class. Just always there. So we always have access to self. The initialization function is expecting us to add properties to the self instance right here. So what I'm going to do here is I'm going to say, hey, self.name, I'm creating a property of this class, property of this instance, and I'm going to set it equal to name right here, which is another variable that's put in. So if I were to create a body part, I would say body part, and I could call it leg, and set it equal to something right there. That would call the init function. Okay, so let's explicitly do that, but let's do it with a heart body part. So I'm now going to create another class called heart, and it inherits from body part. So it has the same initialization function that's right there. But now the first thing I'm going to do is I'm going to add another init function. I'm going to overwrite the initial init that was there. And it takes as input self, as always, but now it's got this thing called rate and units, which are more specific to the body part heart, right, than they are to other body parts. So now I can set up things like self.rate is equal to, how many beats it is per unit right here. And I define the units right here as default to minute and default to 60. So 60 beats per minute. It's a default heart. Now, what I'm going to do here is, what I want to do is I want to call the initialization of my superclass, which is body part. And the way that I do that is I say super, and I tell it the superclass of heart right here, which happens to be body part, and I give it self. And then I explicitly call the .init, and I tell it the name that I want it to have right here. So what this is going to do is it's going to initialize self with these parameters, and then it's going to call self inside of the superclass, and it'll initialize the name of it to heart. So I'll get self.name is equal to heart right here. Now that allows me to do things. I have access to these methods later on inside of my class instance. So once I've created it, I'll be able to call print name or print rate right here as part of heart. So we'll do that. Let's say I'll say, give me an instance of class heart. And so what this does is I say, okay, 1 is the rate, second is the units that I have right here. Self right here is not something I ever explicitly put into the method, right? It's actually just, it will place that in there for me, right? So I never actually put self inside of any of the class things that I do. I just define them with self-defined as the first input variable. So now when I say my heart equals heart, 1 second, and I do this print rate function, it'll go in and it'll print, okay, well, name is equal to heart, and it has 1 beat per second, self.units right here. And that's exactly what it prints out right here. Right, so this is just a very simple example of how inheritance works in Python. All right, let's talk a little bit more. So let's say I have this body part object right here. And the first thing that I do inside of the class is actually just define a variable. So if I define this kind variable right here, I'm just going to set it equal to a really, really long string. And you'll see why I did that in just a moment. But essentially, this is called a class variable, right? It's not a property, it's a class variable, because that variable, no matter how many instances of body part I create, this is the exact same variable across those different class instances. And that's different than a property. You know, different instances of the same class could have different values for their properties. But the kind variable that's created right here, it's almost like a global variable across all of the classes that exist right there. So as an example, if I were to create this myHeart variable, which I defined before as heart equal to 1 second, and then create this generic instance of body part, call it foot right here, I could test whether I print out myHeart.kind, and then I'll print out myHeart.kind is generic part.kind. So this would only be true if this kind variable right here is pointing to the exact same memory location. And if I print out the shared variable that I have right here, I'll get true. I'll print out this very, very long string, right? And then I will print out that that is true, truly pointing to the exact same memory location. So very rarely do we use these type of variables inside classes, but they're important to understand because they can be useful. Now, why I chose this to be a huge string is simply so that it wouldn't be cached by Python. So if I say A and B right here, I define them to be the exact same string, but make them very, very long so that it doesn't cache that memory like we saw it did with integers. Essentially, now when I print A is B, well, these are not pointing to the exact same memory location, so it's going to return false. Okay? All right. So now that we have kind of a basic understanding of classes, let's see what we can do with loops and dictionaries that we've just defined. So dictionaries, what we're going to do here is I'm going to do a couple of operations looping through dictionary examples. So in this example, what I'm going to have here is for k in, and then I'm going to say numlegs.keys. Right? So numlegs was some dictionary that we defined earlier, and the keys of it, I'm going to grab each of the keys and set them equal to k. Then I'm going to print k, and I'm going to print numlegs at the k right here. And if I do that, we can see that, oh, okay, here's me printing out the keys, and then it'll say, oh, bird, and it'll have the values of each of those keys and values that we did right there. So this is a really easy way of looping through a dictionary. But we can actually do even better. We could say for kv in numlegs right here. And in Python 2, we have to say .items. In Python 3, we can just say for kv in numlegs. And it knows that it wants the key and value pair for that. So I'll say print k and v, right? So it'll give us the exact same output, the key and the value. Now, if we want to test for the presence of a key, it's really, really simple syntax. For t in all of these, this list of human, beast, cat, dog, I'm going to loop through there, and t is going to equal human, then beast, then cat, then dog, then 45. I'm going to print out what it is, and then I'm going to say if t is in this dictionary, go ahead and print it out. Otherwise, say that it's not present. And so if I do that, I'm going to say, oh yeah, human is equal to 2, beast is not present, cat is not present, but dog and 45 are there, and it goes ahead and prints out the values. Okay. Now, we've been talking about loops in dictionaries and looping through lists, and typically we're doing very simple operations with a for loop. And it turns out that in Python, we can do those loops in one line of code and actually return a new list of values. And that's something called using comprehensions. So this is a very, very common type of syntax that you'll see in Python. And essentially what it is we're going to give it some operation to do on every single element inside of a list or a dictionary. And basically we're going to say for x in the range of 10 right here. So x from 0 to 9, evaluate what x is to the 4th. And then since I've got these little brackets around it, what that's telling you is to create now a list of all of those outputs from basically this for loop that I have right here. So the output of this would be all of the 0 to 9 to the 4th power inside of this list that I have right here. And I'm not limited by what I can do inside of a comprehension. I can do most anything that I can do in a regular for loop, as long as it's, say, one line of code. I say quest upper equals x.upper for x in questions right here. And so it just, what it'll go through is for every single element inside of this list, it'll return a new list, a comprehension, with all of those completely switched to uppercase. In dictionaries, very, very similar syntax here. What I do here, the comprehension that I defined, I just define a comprehension of for loop inside of curly braces. And what that allows me to do is say, give it the key and the value, right? So I say whatever the key is, colon, and the value that I want it to store inside of that dictionary. And so the value will be x, the key will be x, and the value will be x to the 4th. And if I print out this new dictionary via a comprehension, so really this is just syntactic sugar for being able to create something really, really easily and quickly, because these are types of operations that we do on lists all of the time. We could do this just inside of a for loop, but it might be a little more intuitive, a little more readable to do it this way. Finally, we can also do some interesting things in this. We can use comprehensions and zips and then print statements. I'll show you exactly what this does. So basically, I'm going to say x times y for x and y in a zipped array, right? So I'm going to zip these two arrays together, grab each of the indices one by one, multiply them, create a whole new list of this. So it's this multiplied by this multiplied by this multiplied by this, and then I'm going to sum them all up right here. And if I do that, the answer is 260. And if you remember from your mathematics or linear algebra, if this were a vector and this were a vector, this right here, this one line of code, is defining what the dot product of those two vectors are. So now let's very quickly go in and use what we've learned to update our calculator example. Let's see if we can make it even better using more object-oriented coding and kind of separating out what it is that we're working with in terms of the class and in terms of, let's say, the user interface or the console on how we're using our calculator example. So the way that we will do this is actually pretty simple. I'm using the exact same IPython notebook that we used before, but now I'm going to define class a little bit differently. Right? So before we had this operations list that was just kind of this global variable hanging out in the workspace. Now what we're going to do is define a class called calculator. And inside of the initialization for calculator, that's where I'm going to define my operations list. And I'm going to import operator as OPER. And you'll notice that I'm doing this only inside of the init function. So if I had some global OPER function that was defined outside of this class, I wouldn't be overriding that variable. I wouldn't be overriding that function because I'm only importing this while I'm inside of this initialization function. And now I'm going to say self.operationslist is equal to all the operations that we had defined before. So operations list is now a property of the class, right? It's not a shared variable, just a property, which is typically what we define in classes. And now I can redefine all of those functions that we had before. So we had this isOperation function before, and if I scroll up to the example, isOperation was, okay, is that in the operations list, the keys? And now in my object-oriented example, isOperation, the only thing I pass into it, I pass in self, because that's always the first argument inside of a class method. But then I also pass the value that I want to check, and it's exactly the same. If value is in self.operationslist.keys, return true. Otherwise, return false. My isFloat, well, I can define this as, I can pass in self, right here is the first one, and value, and I'll do it the exact same way as before, return true or false. My convert user input function, I'm going to make that also part of the class method that I'm going to use here, and it's defined exactly the same before, except self is the first argument, and the same thing with perform operation. Self will be the first argument, and then I will have operation and values from that class. So now when I want to use this, all of these functions are subsumed inside of this class calculator. So the way that I'm going to call this code changes just a little bit. So here's what I'll do. First, I'm going to print out, I'm going to create my evaluation queue, my user input, all the same as before. But now I'm going to get an instance of the calculator, right? So I'm going to say, hey, calculator equals calc. And immediately when I do this, it's going to call the init function and set up my operations list. Right, so there's calc. And now I can actually use dot notation to call all of the methods that were part of that class. So user input is going to be equal to, hey, calc.convert user input, and then I will grab the input from the console, from the user. And then I'll add that onto the evaluation list, the queue, and I'll go about this the exact same way as I did before. I'll say calc.isOperation because I've defined that in my class. And I'll put the evaluation queue within the evaluation queue at the -1. And then I can go ahead and access, I can pop off all the different result values, and I can say my calculator perform the operation. I'll give it the result and v1 and v2. Now remember, every time I call calc dot right here, I don't actually have to pass in self. Self is automatically passed in when I'm calling the calc dot notation right here. So even though perform operation is defined as self and then operation and then values, I'm only giving it the operation and the values as a tuple. And then I can put those on the end. So let's see if this actually works. I'll go to my calculator prompt, we'll say 5, and then we'll enter 2. We want to multiply these together. It's 10. It works. Now we might enter 11, and we might subtract those. -1, right? So perfectly, I'll hit Q, and we can exit out of there. Now, that's great. I've taken the first step to making this calculator object-oriented by placing the initialization, operations, and float, but there's still a real problem here. I haven't really separated out the functionality of this calculator. Right? Really what I'd like my calculator to be able to do is I'd like to completely separate it from what I'm doing in terms of calculating, user input. I want this while loop to only deal with using user input, right? I only want it to, take the input values. And I want the calculator, the class, to do the rest of the work, right? I don't want to define my own evaluation queue globally. I want to maybe define that inside of my calculator class, right? And that's where I keep track of my evaluation queue. And so let's take a stab at doing that. So now what I'm going to do is I'm going to redefine my calculator class. Get rid of the old one, define it new. And what we'll do here is we're going to define an init function, and we have an operations list, but we also now have our self.evaluation queue. And when we first initialize, we'll just set that evaluation queue equal to an empty list. And we'll define a couple of queue operations that we can do to this, where we have, clear the evaluation queue. We could have, hey, print the evaluation queue right here, where we just print it. We could also have this function add to queue, right? And when we add it to the queue, that's when we potentially want to be performing operations on the evaluation queue. So what we'll do here is whenever someone adds something to the queue, we will append it to the evaluation queue, so self.evalqueue.append, and we'll make sure that we convert the user input value, whatever that value is that they've passed in. And I'm going to say if it's an operation at the end of the evaluation queue, do the exact same things that we did before. Pop off the 3 values and evaluate what it is, and then place it back on the evaluation queue. Right? I'm not going to really change any of the other functionality that I had right here, but I am going to add one more function in here, which is print operations. When someone calls this, it's basically kind of a convenience method. So it says, hey, these are all of the operations that I perform. And basically, the way that I can do this is print operations will say, okay, I'm going to print operations list right here, and then I'm going to print out x for x in my operations list key. So, and then I'll print out a space at the very end. And what essentially this is doing right here is it's printing out all of the operations that this calculator supports, right? And that's kind of an interesting operation to do. So let's go ahead and use this now. it's really drastically going to simplify our while loop. Because now we're going to say, okay, calc equals calculator. Now that it's initialized, I can print out the operations that are that I support with my calculator. And now I can just say, okay, while true, and say get my user input. If user input is ever equal to q, just break out of this while loop. Otherwise, add it to the queue and print the queue. And that's it. That's all I need to be doing. The calculator is handling all of the performance operations right here, because add to queue actually performs the operation if I put on an operation. So let's see if this actually works. If I run this, oh, here's all the operators that I support. Okay, so we could say, well, let's say 3, 3, and let's divide them. We get 1. And let's say 4 right here, and then we'll take it to a power. I'll take 1 to the 4th power. That's equal to 1. Take 1, and we can take 7 and subtract them. Right. The only thing that we haven't done is, let's say if I put a plus operation right here, I haven't done any type of error checking on this, right? So it still tries to grab 2 things off the queue, and the queue is only of size 1. So this actually doesn't work right there. But what we have done is made this thing almost completely object-oriented, right? We've really simplified the interface for using this class. All of the functionality is hidden to someone that might just be using our calculator class, right? So if we want to make this calculator even more reliable, we need to actually go in and handle some of the errors that might be happening inside of the user entering information incorrectly. We want to guard against all of those things that might happen if the user enters information incorrectly.